Hello, everybody. Thank you for being with us today. I'm Morgana, and Gianni is my colleague that is with me. We'll speak to our presentation about our almost 1 year long journey about RAGs from the click deploy to production. We are talking a lot about RAG technology and architecture today, but maybe it's worth to recap what these solutions are and why we may need them. We can think to an assistant like a digital colleague, able to interact with the users via natural language that is capable to provide an intelligent and adaptive support. I'm talking about a colleague because they know your business, they know your data are always available, and they are capable to adapt to your needs and level of expertise. So if you are a dev, you are expecting using some specific technical language. Otherwise, if you are no technical person, you are speaking in a different way. RAG are able to adapt to, the assistant are able to adapt to different needs and level because they are exploiting, like I was saying before, RAG or Retrieval Augmented Generation architecture that basically empowers an LLM with a retrieval information system. This works in 2 steps. First of all, we have the retrieval, in which the system understands the user query content and meaning and retrieve relevant information, and then this enriched context is served to the LLM that in this way can provide a contextually grounded response to the user. We said before in the previous session, but worth to repeat, why we didn't fine-tune and go through this kind of solution. The reasons are basically in 3. First of all, we want to have something that is cost-effective because fine-tuning large language models require lots of solutions, lots of resources, lots of cost. Then we need something that was reactive to any changes in our data and system, and updating the knowledge base of the RAG solution is very quick. And then we want transparency. What is very important when we speak about RAG instead of speaking about generic LLM application is they mention their sources. So the user can always verify why the model is returning something by checking the original document that was used to craft that response.
Morgana, can I ask you something?
Do you want to use this one?
Yeah, I use this one. So, can I ask you something? You were mentioning RAG system and fine-tuning. What about agents?
Yeah. Agent, like a previous session, were exploring to us that was really meaningful and useful. We can say that RAG is the fast thinking. In RAG, we have a predefined protocol in which we have an LLM and always exploit the RAG, so the knowledge base to retrieve. Instead, agents are what is calling slow thinking. This is an evolution because we are providing an LLM with the capability to resonate, plan what to do, and then exploiting tools act, and then observe and iterate through this process until it's concluded. There are 2 different approaches. They have some pros and cons on both of them, and of course there is also the possibility to combine them, as we saw in 2 sessions ago. To move back to what we did, we started this project exploiting Azure services, basically 3 of them. Azure OpenAI service that combine OpenAI generative models like GPT-4 or 4o with the Azure enterprise capability, so in terms of access, security, and scalability. Then we exploit the chat with your data that during our exploration changed names 3-4 times, yeah, just to create some confusion on the documentation, that basically provide the capability to connect large language models with your data and also to define the behavior of how this model is going to interpret stuff. because every time that we are speaking about an application based on LLM, we are implying that we are defining a system prompt that are an internal message in which we are saying how the LLM has to interpret and generate response. So, for example, if we are building something very specific for developers, maybe we are asking to use technical language. Otherwise, we can ask to use a different kind of language, craft responses like Markdown, JSON, more or less structured. And finally, we exploit the Azure AI Search, that is the core of the RAG, because it's the one implementing the retrieval system. We spoke a lot about the ability of the RAG to retrieve what is relevant. This implies to select some different searches approach. Azure implements 3 of them. The first one that is the most common when we speak about LLM is vector-based. So like we saw before about chunking, embeddings, and converting everything to number. So understanding what is related to each other is just a meaning of measuring numerical distance. Then we have the classic keyword search, one-to-one matching. If a document reporting this keyword, then we want it. And finally, the semantic. The semantics means to expand the meaning of a concept to every possible direction. To clarify, if a user is asking something about capital, maybe he wants to learn something more about the geography of a country, but he could or she could also want to know about legal stuff, because if we are linking capital to crime, we are changing a lot the meaning of the user intent. Azure implements all of them, and we saw that the AI search is the core, because it is the retrieval system. To deep dive a bit, this is made by 4 components. First of all, we have the data source, connecting the original data to this solution. Then we have the skill set that are a list of functions saying in which way we have to prepare data to be digestible and usable by the system. For example, if we want to implement a vector search, we need to chunk to embed the information. And then we have the index that is the responsible of preparing data according to the skill set, saving them to the index that is the assistant knowledge base. This is the architecture on Azure. So we have different kind of data source. We prepare them, store, and then the user that can interact with RAG, with the assistant, with, for example, a web app chat interface, send his request, and the orchestrator manage to retrieve relevant information, serve to the LLM that can return the response. And now the most interesting part. I always have demo effect, so I prefer to record it in advance, but then we can exploit some practical example, chatting user, some question, if we have time. Yeah, this is starting. So we just need to deploy Azure AI sources. Then we move to deploy models. For example, I select GPT-4o and text embedding because I also want to implement vector search. And then moving to the chat playground, following the instruction, we can create all the resources we need. So the indexer, the skill set, everything, uploading the data, and select what kind of search we want to implement. In this case, I also want to exploit vector search, so I selected also text embedding data. Then upload some documentation. Not much creative, I upload documentation about what I'm talking about. So if something is not clear, we can ask through the assistant to solve your doubts for me. And then we select the kind of search. In Azure, hybrid is the combination of keyword plus vector, that is the basic, and we also selected the semantic. So we want to exploit all the 3 mechanisms to get the best from documentation. Then we have to define the system prompt, so their internal messages, internal instructions that I was speaking before. In this way, I'm just saying, please be aware that we are speaking about Azure AI capabilities. I'm providing you with documentation. You have to be clear and responsive to solve user doubts. And finally, set up the parameters. I want the assistant to be not very creative, so setting the temperature very low, and then I can just test it. I ask what is Azure Foundry in this example, because until a couple of weeks ago, it was called Azure AI Studio. It was creating a lot of confusion because inside we have Azure OpenAI Studio. Now they are changing names. However, I tested, I got my response, I have the resources that, the document that the system is exploiting. I can check it going through them. And then, because I was satisfied, I can deploy it as a web app. These steps require around 10 to 15 minutes, but we'll create everything that we need. So the web page, the plan, everything. But it's super quick. It's just around waiting 10-15 minutes, defining the system prompt. So getting started with this kind of solution is intuitive. Then I see at the end of the demo the interface that we open. Of course, on the other side, this that is so well packaged into something quick and ready that we call click next has some downside because the level of customization that you can apply is limited. The way in which you can enrich and prepare the data is quite limited, or at least very complex to modify. However, it's a very interesting and starting example. What is worth to mention here is also the possibility to create a chat history. So if you are sharing with a bunch of colleagues just to get their feedback, you can say, okay, you have the doubts, start a query and ask him something to your system. If you change topic, change the chat, because when you interact with an assistant, it exploits all the past messages to get the context. So if you change topic, change chat. But with the chat history, if you find some additional cues or something that is relevant, you can come back and start exploiting them back.
I have a question for you, Morgana. So you'll tell me that in 15 minutes I can put on a chatbot, have my documents ready, and give all the users of my company, for example, this stuff?
Very good question. In terms of the time that you need to set up, it could be around 20 minutes, just taking to select the documents. But of course, there is a huge work about the data preparation, because the data that we are feeding our system with and the way in which we are preparing has a great impact about this kind of solution. More than data, I prefer saying knowledge, because like we saw, the strength of this solution relies on information that we are feeding to the system. But the information is more just technical textual documentation. For example, we deployed an assistant for an internal purpose, and we found that the best way to find knowledge was, first of all, be very clear on the scope, what we are expecting from this assistant. Then collaborate a lot with the final user, because they know what they are expecting from this solution and where the knowledge is. Still speaking about knowledge, because, for example, we discovered that what was very relevant, the cues and the tips about solving particular problems were exchanged by user in Teams chat, dedicated team chats. So what we did in that case was collecting this chat and through an LLM convert into structured document. This is why, because LLMs get the best by structured documents. They love, at least for now, PDFs. And with this kind of tools, we can understand and extract information for other sources other than documentation, textual documentation. We also exploit internal training video to get some cues, and we convert this kind of video into textual document and feed it with the assistant. This is a very brief and simple tool of prompt, of what we did, but is giving you an idea that preparing data requires a lot of the research at the beginning to understand the data that we want to include, the data source that we want to include, and understanding in which way we must prepare. But in the end, we are speaking about a few lines of code, providing them to an LLM and get it. So the first time, like any data scientist process and project, around 80% of the time is consumed about preparing and ingesting data. But then, yeah, when you have it, it's just around 50 minutes. So we were very happy when we were at the end of this first step of our proof of concept of POC. And so the natural next question was understanding how good the solution was and where we must improve to be something effective. So we create a two-level system of feedback collection. One directly in the app with a thumbs up and thumbs down, and especially in thumbs down, we are asking users to provide the reason why it was not so good. And then through dedicated survey to get a deeper level of insights about the impact, how useful it was, how intuitive it was, because we say that we're speaking with natural language, but maybe just to have a web chat on a specific web page is not enough. You would like to have it integrated into Teams or your coding environment or whatever. And then we ask how to use this information. Unfortunately for us, we didn't have ground truth, so we cannot directly compare the responses returned by the model with something that we know, this is perfect, this is what we are aiming to. So once again, we exploited large language models to make our evaluation. This approach is called LLM-as-a-Judge, because we are providing an LLM with the capability of assessing how good a specific aspect of a question, a task is. These trees are three metrics that are part of much larger suite of KPIs, and they are just showcasing the capability of the LLM to judge, for example, how good was the assistant in understanding the user query. If we take back the example of the capital was about capital crime, was about geography of a specific country. Then we want to understand how relevant was the response. If the user is asking multiple questions, is addressing to all of them, or is missing the main point? And finally, the groundness. So how faithful these responses are. Is really using our information or its basic and static knowledge? Once again, this is an example of the prompt that we use. This was based on TrueLens because last year was a very promising framework, but right now there are several new frameworks that provide a deep level of monitoring and developing and debugging, of this solution, like LangChain, Ragas, Llama. We have several. And now I leave the word and the work to Gianni, because after we collect all these first inputs, we decide to move into production to industrialize this kind of solution, strengthening all the areas that we identify as relevant.
Yeah, exactly. Thank you, Morgana. So the idea that she explained us took around 6 months, right? So we started last year and did a 6-month exploration on data, and then 15 minutes for deploy. Then it took much more time than 15 minutes because under the hood, Microsoft Azure changed services, changed stuff, and we'll see in a moment why decided to then customize everything. So these are the main challenges that we faced, talking also with other colleagues that use the prototype system. And now we are at the tip of the iceberg, because under the hood, there is a lot of stuff that is not machine learning related, it's not LLM related. It's all the problem of developing software and moving it into production. So just to have a recap, we started from this POC architecture. We leveraged what was already available and is currently available in Microsoft Azure. So you really go to the Azure portal, you deploy the Azure OpenAI service, put some database under the hood. In the specific, we use Azure AI Search and OpenAI service for LLMs. And then we had some customized stuff around the data pipelines. Data pipelines for the prototype worked only on her machine, and so we had to decide how to properly deploy it in a production environment. Discussing all together with the requirements with many teams in the company, we come up to this high-level overview of the solution. So they wanted to have a web application to chat with, so the standard chatbot system. They also wanted it integrated in Teams, for example, because most of our conversation happens in Teams. Then also ask, why don't we integrate in Visual Studio Code? Yeah, we have Amazon Q, we have GitHub Copilot, but we need special stuff, for example, on internal documents, internal code bases, how we can leverage our internal stuff as well. So we envision ways to integrate everything through one only system, one backend API, that then spread the stuff around the knowledge database, the embedding parts, the LLMs parts, and the data pipelines. The idea is that we have a component, building blocks component system, so we can put in, put out, depending on what we want to implement easily. And to do that, we come up to these customization needs. So they wanted an all-in-one assistant. An all-in-one assistant meaning what today you can find in ChatGPT. So you go to OpenAI, you have the GPTs. They wanted exactly the same stuff. So we started working on this stuff. They want to be cloud agnostic. We have some deployments that are on premises. We have for our clients, we have internal stuff that's run on Azure, runs on Google, and runs on Amazon. So we had to build it cloud agnostic. Then also from the initial usage of the system, and also from the demo that you quickly saw in the video, we didn't have a way to currently gather a correct feedback from the usage of the tool. So we had to envision a way to properly get back the user feedback in a more structured way, and also keep track of all the interaction with the system. Just using the sample application that you click, next, deploy was not enough. So we also had to integrate the enterprise guidelines, security aspects, scalability aspect, internal rules that we have, and then also add the customization side, so we want to, in multi-language, we want to customize the colors, aspect and stuff like that, also for the integration in other applications. And then, of course, all the standard monitoring, optimization parts, logging, and security. And then we come up to this high-level production architecture, V1 architecture, that's currently working and in production. Just to make you aware, we have the knowledge database, which currently is based on Azure AI Search, but can be swapped out for any kind of knowledge database. So also on-prem one, local one, whatever you want. We have Azure OpenAI, but we also can swap in, swap out with other kind of models. Then we have a simple web application that we'll show in a moment, and also the only one backend API. This is the true core of everything. And we'll see in a moment which frameworks we will use, especially those two. On the other side, we have the data pipeline ingestion. So we have put in place a set of data pipes that instead of running on Morgana's machine, now currently works within all the deployments. Everything is hosted in Kubernetes, so we can swap in, swap out the deployment stuff and scale it as per need. And then we support many, many data sources. So we have Teams chat, we have web scraping stuff from documentation, we have internal content on Zendesk and on Jira, for example, and everything is stored in local storage that can then be ingested in Azure Search through customized stuff. And we'll see in a moment how we deploy it. So we started from these two examples. They are reference applications from Microsoft. They are all open source. You can grab them from these web points, this repository here in GitHub. This one is the one that you do on click next from the Azure portal. So if you want, you can see the code under the hood, the solution that we deployed out of the box. The point is that it was developed in Python. Why Python? Because Microsoft likes Python. Most of the people in the data science parts are working in Python. So it's very easy for them to make it. But then we move to this other sample here, which is much complex and leverage two stuff, the semantic kernel and kernel memory and ASP.NET Core. In Delta Tre, we are usually on a Microsoft stack, so most of the company knows this technology, so .NET, ASP, and React for the front end. So this was the first idea to move everything there so that we as Innovation Lab develop the stuff and then can gather helps from other colleagues that are more experienced than us on many topics. What we added the quality here and moving from Python and the basic application to production is using semantic kernel and kernel memory. These are two interesting projects. They are currently under development, heavy development from Microsoft, which help us in these points. So, semantic kernel is the go-to solution for production-ready stuff related to LLMs interaction and agentic frameworks. And then we come up to this later. It is enterprise-ready, so you can deploy it, it is supported. You have a lot of community effort, given it is open source. You go to GitHub, you have the Discord server where you can chat with the development team if you have an issue. There are many plugins, so if you want to connect to any kind of database, any kind of sources, if you want to do ingestion of any kind of documents, you already have one plugin. If there is not, you can implement it very easily. And most important stuff is that it's cross-platform. So if you want, you can deploy it using .NET. If you know Python, you can mix and match .NET code and Python code, as well use it in Java. From the other side, from the data pipeline and the data ingestion, there is the counterpart of kernel memory. Kernel memory is another framework which does exactly what we wanted. So it provides us the pipeline, the orchestration stuff, and the deployment and the customizability that we wanted for working on different kind of documents, integrating different kind of preprocessing stuff, preprocessing with LLMs and without LLMs, and then do the upload in the Azure storage for the further ingestion on the index. It is, again, community supported by Microsoft as well. So if you need any help on missing stuff, etc., you can go to the community, go to GitHub, either take example and implement yourself, or you already find out many connectors, like they call it, where you can use to ingest your own data. We leverage this because at the end, the data pipelines part, we were discussing internally how to properly build it, but looking at the code of the kernel memory implementation was exactly what we wanted, because you can have two different approaches. One is from the client, from the backend API that we implemented, you can use the memory service embedded in the solution and ingest document, for example, through the chat. So while you're inserting images, documents in the chat, you will go through the pipeline, the same exact data pipelines that you then have also on the batch ingestion of knowledge sources that we have. And for the knowledge ingestion, we use the version of the kernel memory deployed as a service. So we have batch processes, jobs that run frequently, and you can, of course, configure the frequency of the data ingestion and data in preprocessing. And you have already all implemented. You have login, monitoring, and stuff like that, all already. Then, if the data pipelines that are already there implemented are not enough for you, you have all the stuff to build your own customized stuff. We, of course, went to this solution as well, because some of the logic was perfectly fine with the default pipeline. So we have the context extraction, the chunking strategy, the vectorization. But for example, if you want to do chunking differently than the provided one, you can implement the most recent papers, for example, on how properly structure the chunking mechanism. Or if you do want summarization, for example, you can implement a custom pipeline to ingest, for example, videos, extract the audio, transcribe it, convert it in the format that we want it for internal purposes, and then store it in the index, and stuff like that. Just to give you an example, pipelines are kind of this. So there are console applications, which you can define on different steps here and here. So the input and the output. Of course, this is a very basic sample, but you can imagine have all parameterized. So from the external point, you can point to different folders, different sources, and all apply this kind of steps or other steps that you can define. Let's try to do a quick demo. So I recorded it, but it should work also on my machine. So we can start the the application. Like this.
We are a bit terrified by them.
Yeah. So this is run on this machine, suppose it. Under hood, we have the backend API. Currently, these are a very old prototype version, but you can imagine now, internally we deploy it with customized graphics and more additional stuff. But in the end, we have a backend API server, one from one side. It is fully .NET compliant with all security in place. You have a minimal API stuff here. So if you know a little bit of the boring parts of software engineering and web deployment, exactly is this one. There is no fancy AI under the hood. Here it is a UI. So we'll be able to integrate the chat GPTs and GPTs like. So we have multiple assistants from our side, so the user can pick one of them. We have the possibility, like you have in ChatGPT, to pick random or predefined questions. We also had, for example, you can customize them. So you have a different system with different system prompts, different kind of documents that you can have access to. You have the possibility, for example, to have the history and then the feedback part. So we have some information here that is useful if you want to know the token usages, if you want to know how the answer was crafted, and then also the evaluation side. We implemented the a 5-star system with additional feedback. So for example, we can understand if it was positive, negative, with the issue, with the answer, the provided answer, and also open for comments. So we listen to our internal users and try to implement this stuff for their needs, and everything can be deployed through some pipelines in a Kubernetes cluster. Morgana, after almost 1 year, which are the lessons that we learned we can share with the audience?
Yeah, we try to summarize the main lessons that we learned during our journey. First of all, data is king. Without data, this kind of solution is completely worthless. And it's fundamental to collaborate with the final user of this solution because they know the knowledge, what they're expecting the assistant to do, and where this kind of information are. Because in the end, we are aiming to create something like the colleague that you chat with in front of a cup of coffee, this kind of insights. Then we have several ways to retrieve what is important. It is fundamental to exploring in different direction and trying to combine what is relevant. So not all the possible approach, not all the possible data, but what is relevant, what is meaningful, and what can help. And then this is something that is not, and the first one, you got everything, is something iterative. You have to start, collect feedback, understand, share with your user best practices about how to use this kind of solution, in which way is a continued learning journey altogether.
Yeah, then from the other side, we learn how to properly evaluate the feedback. So LLM-as-a-Judge is one of the approaches. Then from the new implementation that we could do in production, we also gather the answer from the users. We know the knowledge store, and we craft together with the users the ground truth, for example. So we know that given a specific question, we expect some specific answer from the documentation that we provide. So we evolve also on the LLM-as-a-Judge technique. We also been able to implement all the security side. So we didn't go deeper on this, but you can imagine in a company or in general with clients, you have documents that can be accessed by everyone, but also can be accessed by just limited people. So we also implemented all this logic under the hood that if you go just with the next solution, is not there. And then we have implemented all the best practice for GitOps, for example, the continuous improvement. So if you want to deploy a new version of the assistant, it's just a matter of 10 seconds, probably. Go to database, change some stuff there, some of the settings there, and we have the new version. We can also go back and forth the version of the assistant, their configuration, or the under the hood, the system prompts. And we didn't discuss it, but there are many plugins under the hood, so they can surf the web, they can go search within the documentation, and some interesting parts that we can discuss later if you want.
And then to conclude, of course, something about what's next. Different direction could be used to answer to this question. First of all, in terms of evaluation and monitoring, to get to not lose the fundamental feedback of the user in which way we can improve. Then about the scalability of this solution, so to be updated with growing data volume on your user demand, and then about the approaches. So the agents seem extremely providing right now, but also implementing way in which we are connecting data before, like graph RAG, in which we are transforming the information like a graph. So we are pre-connecting stuff in some ways to favor in some way retrieving what is correlated to each other. And that's all. We thank you very much for your attention. I'm happy to share to any question you may have.
Okay.